Okay, here's an interesting question, and it's an okay question, but it'd be nice if the ratios went 1 to 1 to 1. 1 to 1 to 1 are okay because they all go up or down by the same amount, and so they're fine. But it's nice when those ratios are not 1 to 1 because it makes you push a little bit. Anyway, let's make up our ice table. So initially, and what do we have? On the left side, we got NO2 and NO. And then on the right side, I've got N20 and I've got O2. And all the ratios are 1 to 1 to 1 to 1. Okay, so initially, change equilibrium. Going a little crazy with my lines here. Okay, so it says originally the N20, oh, they're messing me up here. N20 is 0.184. 0.184. And that's concentration, good. O2 is 0.377. Okay. And O2 is 0.0560. And NO is 0.294. And those are all moles per liter. Okay, so then they say the NO2 was monitored and became 0.118 at equilibrium. NO2, that's this first one. It became, what did they say? 0.118 molar at equilibrium. So then they say calculate the equilibrium constant. Okay, so when you're doing this, you've got to take a look at what's changing. And typically, or what always is going to happen, so this whole side will do the same thing, and then this whole side will do the opposite. And you just have to figure out which one's going up and which one's going down. So on this one, if I take a look at NO2, and that's the one I know 2 pieces of information about, it starts here, and it looks like the concentration goes up. So this one's going to go up. So if that one goes up, then this one has to go up as well. If those two go up, so they're creating those, so your equilibrium, let me write, oh, here's my reaction up here. The equilibrium here, if I'm creating more of this and this, they have to get it from there and there. So these things, so if these two, if this one goes up and this one goes up, then these two over here both have to go down. So this one has to go down and this one has to go down. And they all go up or down by the same amount because the ratio is all 1 to 1 to 1 to 1. So if this one, it's not, but if this one, say, goes up by 3, then this one would go up by 3. And then on the other side, this one would have to go down by 3, and this one would have to go down by 3. Okay? So now we just have to figure out how much things are going up by. So if I ended at 0.118, let's do my calculator here. And it started at 0.0560. So 0.118 minus 0.0560, 0.62. So this number, it goes up by 0.062. So if that one goes up by that, since it's 1 to 1, this one also has to go up by the same amount. And since it's 1 to 1, these are the products over here on this side, and we use those to create more of those reactants. These ones have to go down by 0.062, and this one has to go down by 0.062. Okay, so now we just have to do my adding and subtracting. This one was going up, so it'd be 0.294 plus 0.062. So that'll give me 0.356. Then on the other side, 0.184 minus 0.062. This will be 0.122 at equilibrium. And the last one, 0.377 minus 0.062 is 0.315. So those are all the equilibrium concentrations. Now I can do my equilibrium constant. So it's going to be products, so it'll be 0.122. There's no coefficient out front, they're just ones, and so I don't have to put any exponents up top here. So there's none of that. Times 0.315 divided by the product of 0.118 times 0.356.